Okay, so today we're going to be having a look at horizontal translations of quadratic functions. And of course, where am I going to begin? Well, we're going to begin off by looking at it in general. So if I have a function f of x and I would like to translate it, meaning move it, b units to the right or c units to the right, it becomes f of x minus b. Alrighty, so that's the transformation that needs to occur. So we're going to be having a look at doing this for quadratics. So we know what a quadratic looks like. So here's our happy little quadratic. And what we can do is we can think about what a horizontal translation would look like. So for a horizontal translation, it just means that we're sliding it either left or to the right. Now, many of you will notice that there's a minus sign here instead of a plus sign. That's going to be a common theme whenever we're doing these transformations. So for a function f of x that's equal to x squared, when we translate it, well, it's going to become x minus b equals x minus b squared. Okay? And this can be combined with our other transformations as well. So this is moving the quadratic b units to the right. Meaning, if it's minus 6, that's 6 units to the right, but if it's plus 3, that's 3 units to the left. So just be mindful that it's always reversed of what you might think. When you subtract, it's moving to the right, and when you add, it's going to be moving us to the left. Alrighty, so let's look at an example and see if we can sketch it. So y is equal to negative 3 x minus 5 squared. So this is our function we're looking at. So let's first of all, let's look at the fact that there's a negative at the front. As soon as we see that, we should be thinking immediately it's been reflected, which means it is no longer going to be concave up, it is now going to be concave down. Something like that. Alrighty, at this point I'm just sketching, I'm not trying to get any too fancy. But notice even when I reflect it, that origin point's stuck in the same spot. So that's dealing with the negative. Let's look at the 3 next. Well, the 3 is dilation, and it's going to be a dilation in the y direction, so it means it's going to be more stretched out, so it's going to look even narrower than it did before, and it's still going to be negative, so there is the negative and the minus. And now all we need to do is the translation, which is move it 5 units to the right. So that's translate 5 units to the right. Alrighty, so let's do it. So since the original point was here, 5 units to the right would be 1, 2, 3, 4, 5 units here, and it's going to be the exact same shape, just having moved. And you notice really, when we talk about translating, the main interesting point that gets translated out of everything is going to be that turning point. So the turning point used to be at 0, 0, and it's now been moved to 5, 0. It really makes it a lot easier to sketch a quadratic if you can do something like that. Now, if we wanted to find the y-intercept, we know it's going to be down here somewhere. But if we wanted to solve for it, well, the y-intercept is when x equals 0. So it shouldn't take us too long to work it out. Y is then equal to minus 3, 0 minus 5. 0 minus 5 is negative 5. Negative 5 squared is 25 positive. So it's times 25. So the intercept is going to hit at 125, negative 125. So it's a fair way down on this axis. So the coordinate would be 0, negative 125, way down there. But it will hit the y-axis eventually. It always does, unless there's a domain restriction. Alrighty, so there's our first sketch. Let's try one more. Alrighty, so in this case, we don't have a negative out the front. In this case, instead, we've got a coefficient of a half, which means that it's a vertical dilation, but it's actually getting closer to the axis. So let's draw our original one on, and then we're going to have a go. Alrighty, so y equals x squared, I'm going to do in blue. So this is our original function, and I'm just going to leave it here for the remainder of this little section. I'm just going to make it look nice. Well, as nice as I can make it look. Alrighty. So there's the original function. Now, the fact that it has a half written in it means that it is going to be even closer to the axes, which means it's going to kind of come up a little bit more gradually, maybe slightly wider than the previous one. Obviously, it should be symmetrical, but, you know, can't always give that symmetry. And the other part about it is that it has been +2. So that is translated 2 units to the left. Alrighty. So 2 units to the left would move the turning point there, and now we can sketch the same shape, just moved over a little. Alrighty. And that would be y is equal to a half x plus 2 squared. Alrighty. So there's a little bit on translations. And next lesson, we're going to look at how to combine all of this together. See you in the next one. Goodbye. Oh, just before I go, if we wanted to talk about the axis of symmetry, you can see the axis of symmetry has indeed moved, and it has now moved to x is equal to -2. So sometimes you may want to know what the line of symmetry is. And in this case, it has been moved to the new turning point, the x coordinate of the new turning point. Alrighty, see you in the next one.